Hello everyone, welcome to Victory Batch. This is me Arvind Suthar. I welcome you all in this session on limits. So this is going to be our final lecture in this series, and we're going to be nailing this topic because usage of this topic is there in class 12th as well, because in 12th you will be going through topics like continuity and differentiability, and here is the usage of this particular chapter. So let's go and let's nail this particular session. Limits is all about indeterminate forms. What are indeterminate forms? The indeterminate forms are the forms which can be determined but after certain manipulation. Understand this particular thing. If I am saying that a number is written like this, in which numerator is going towards 1 and the denominator is going towards 2, then this number will go towards where? You can definitely say that it will be going towards 1 by 2 only. It will be going towards 1 by 2 only. If I say a number is moving towards 0, in the numerator and in the denominator it is moving towards 1, then this number is moving towards where? You can definitely say that this number is going to be moving towards nothing but 0 only. But if I give you any of these forms, any of these particular forms, these 7 forms, then the answer will be what? You cannot say without manipulation. This is not 0 upon 0, because I hope you guys know that in mathematics 0, division by 0 is undefined. So this is rather tending to 0 upon tending to 0. Tending means close, almost close to 0. What are the numbers which are almost close to 0? They are nothing but 0.00000000000000000000001. On the left hand side, if you see on the number line, what is the closest number to 0? Minus 0.0000000000000000001. Yes or no? So here I am talking about that. Because in mathematics you already know that division by 0 is not defined. Here also this is tending to infinity upon tending to infinity. This is tending to infinity minus tending to infinity. This is tending to infinity into tending to 0. This is tending to 0 to the power tending to 0. This is tending to infinity to the power tending to 0. And this is tending to 1 to the power tending to infinity. So these are all tending. Tending means close to, not exactly. Okay. If I say something like this 0 and if I say tending to 0, these are both different things, because this particular thing means exact 0 and this particular thing means close to 0. I hope you people understood this particular thing. Okay, as the name suggests, we can't determine the values in the present form, so that's why we do the manipulations to find out the values of certain kind of things. Let me give you a few examples over here so that you can understand this in a better way. Let's say I give you something like this: limit x tending to infinity x upon x. Now as x is moving towards infinity, this x will move towards where? Sir, this will move towards infinity. This x will move towards where? Sir, this will move towards infinity. I said okay. Now if you do the manipulation and if you cut these two things out, then this particular thing is going to be what? Limit x tending to infinity 1, x tending to infinity 1. So this answer will be what? 1. Okay. Now look, the form is tending to infinity upon tending to infinity and the answer is coming out to be 1. If I take this particular kind of an example, now this particular thing will move towards where in this case? Infinity, yes or no? Because 2 into infinity is going to be again infinity only. I said okay. Now here if you cancel out x and x, so this is coming out to be 2 or not. So understand that in both the cases over here, the form is tending to infinity upon tending to infinity only, but in the first case we are getting 1 as the answer, in another case we are getting 2 as the answer. So this does not happen in the determinate forms. As I told you, if you ask about tending to 1 upon tending to 2, this will go towards 1 by 2 only. If I ask you about tending to 2 to the power tending to 3, then it will go towards 2 to the power 3 only. This is predictable. Without any manipulation, you guys can say that the answer is going where. But these are 7 indeterminate forms in which you cannot predict that the answer will be moving towards where without manipulation. I hope you guys are clear with this particular thing. Okay, so now understand that if x is moving towards 0, then cos 0 move towards 1, yes or no? So this particular thing will be moving towards 1. This is not exact 1. Because I am saying that x is approaching 0, x is not equal to 0, x is approaching 0. Approaching 0 means it can be either 0.000000000000001 or it can be minus 0.00000000000001. So this particular thing is not defined for x equal to 0, but here in the case of limits I am talking about the neighborhood of 0, means I am talking about 0.0000000001 or minus 0.00000001. I hope you people understood this much. So this numerator will be moving towards 0 only, and denominator is also moving towards 0. So here we need to do certain manipulations so that we guys can find out the value of this answer, because the value of this particular question, because this is one of these 7 determinate forms getting formed over here. If you look at this particular thing, then if x is moving towards 0, x is not 0, if x is 0, then this will be exactly equal to 1. I am saying that x is moving towards 0, x is approaching towards 0, x arrow 0 means x is approaching 0. So we can say that this particular thing is moving towards 1. And this particular thing in that case will be moving towards infinity. So this is tending to 1 to the power tending to infinity, and this is nothing but an indeterminate form. So here also we will need some manipulation, and then we can find out the value of this particular thing. Here also if you see x is moving towards infinity, so this number will be moving towards infinity, and this number will also be moving towards infinity. So this is nothing but tending to infinity upon tending to infinity. So here also this form happens. That means we will need to do some manipulations over here so that we guys can find out the value of these limits. Okay, now let's talk about method number 1, and that is substitution method, direct substitution method. It is used when limits is not in indeterminate form. If indeterminate form is not getting formed, then you can directly substitute the value. Like I will tell you, let's say I want to find out the value of this particular thing. Okay, now x is moving towards 1. So this x square will move towards where? Sir, if x is moving towards 1, then I just told you this particular thing will move towards where? Sir, this is not an indeterminate form, so we can say that this will move towards 1 only. So I said fine, okay. And this tending to 1 plus 1 will be moving towards where? Sir, this is not an indeterminate form, so this will be moving towards 2. So we have got the value of the limit. Now understand, in place of this x, if you put x equals to 1 also, then also the answer will be coming out to be 2. So we can put directly x equals to 1 and can get the same answer. Why? Because indeterminate form is not getting formed over here, and that's why we can simplify this method to direct substitution, that is directly substitute x equals to 1 into this. Why? Because indeterminate form is not getting formed, so this will be 1 plus 1, that is equals to nothing but 2 only. Here also x is moving towards pi by 2, so this particular thing is moving towards pi by 2. The sign of pi by 2 will move towards where? Feel it, 1, yes or no? Yes, so we can directly substitute the value because there is no indeterminate form. Over here also if you see, x is moving towards 1, okay, limit x tending to 1. Over here also this value will be moving towards where? Towards 8, and this value will be moving towards where? Towards 6. So is it an indeterminate form? No sir. So we can directly substitute x equals to 1 in both numerator and denominator. We will get this as the limit. I hope you guys are clear with this. So we can use direct substitution method whenever indeterminate form is not getting formed. There are these 7 indeterminate forms: tending to 0, upon tending to 0, tending to infinity, upon tending to infinity, tending to infinity, minus tending to infinity, tending to 0, into tending to infinity, tending to 0 to the power tending to 0, tending to infinity to the power tending to 0, tending to 1 to the power tending to infinity. Apart from this, there is not going to be any indeterminate form, so just remember all these forms, because we're going to take these forms one by one and we're going to solve some amazing questions as well in this particular session. In all indeterminate forms, if you see, if we are calculating the limit x tending to a, then at x equals to a, the function is not even defined. You guys can feel it, because tending to 0 upon tending to 0, okay, at x equals to a, the denominator will be definitely equal to 0, and in mathematics denominator will never be equal to 0. Okay, you must know these very basic things over here, that is, if in between two functions plus is written and the entire function's limits is what we want to find out, then this can be splitted like this: about, plus or minus. About this plus minus, we can, if plus or minus is there, then we can split this limit. If multiplication is there, then also we can split it. If division is there, then also division of the two functions is there, then also we can split the limit. But limit x tending to a g of x must not be equal to 0. If the denominator becomes equals to 0, then we cannot do this. Okay, so do take care of this thing as well. Okay, number 2 method is factorization method. You might have learned this in class 10th, and that if x is a 0 of the polynomial p of x, then x minus a is going to be a factor of p of x, yes or no? Yes, you might have learned this thing in quadratic equations chapter as well. So here we go, let's solve this particular question. In any question of limits, if you are solving any question of limits, what you do is you first put, let's say, x equals to 2 over here. Then this thing is going to be what? This thing is going to be 3 to the power 2 minus 1. So that means this thing is moving towards 3. Similarly, if you put x equals to 2 over here, then this thing is also moving towards 3. So don't you think that denominator is moving towards 0? Yes, sir. Okay. Then over here, this will be moving towards 9. This will be moving towards where? This will be moving towards 3. Minus 12 if you do, don't you think that the numerator is also going towards 0 only? Yes. So it is tending to 0 upon tending to 0 form, indeterminate form. So we can find out this limit only by certain manipulations. We can find out this limit only by certain manipulations. So now let me tell you one shortcut method which is useful for you in JEE examination. Whenever tending to 0 upon tending to 0 form, whenever tending to 0 upon tending to 0 or tending to infinity upon tending to infinity form is there, use LH rule. LH rule. LH rule is what? Differentiate numerator and denominator separately. Differentiate numerator and denominator separately. So this is the concept. I would like to tell you about differentiation as well, though you might have studied this in physics, but still, if you know differentiation a bit well, then you can solve all these problems like in few seconds only. Okay, so you must know the differentiations required in the problem. If a to the power x differentiation with respect to x is required, then this is going to be nothing but what? It is going to be nothing but a to the power x into ln a. It is going to be nothing but a to the power x into ln a, people, right? Okay, you must remember this particular thing. Okay, one thing is this. The next thing is chain rule. The next thing is chain rule. Let me tell you about that as well. Chain rule. Now, chain rule is quite an easy thing. If you want to differentiate, let's say, differentiation of a to the power x minus b, okay, with respect to x, then what you do is, you first write down this particular thing as it is. You first write down this particular thing as it is, then ln a, and then you do the differentiation. Let me say if it is like this, cx, then cx minus b, then you multiply it with c as well. This is how you differentiate. You will learn differentiation in class 12, so don't worry about that. Now I think you can comfortably solve this question, because tending to 0 upon tending to 0 or tending to infinity upon tending to infinity form is there. That means we can use LH rule, and the LH rule says that differentiate numerator and denominator separately, and these are the formulas for differentiation I have written for you. As of now, you can remember these formulas. In case you are not good at differentiation, don't worry, differentiation is a complete chapter in class 12, so I think you will be able to understand it over there. So since it is a tending to 0 upon tending to 0 kind of a form, so let's differentiate numerator and denominator separately. So over here, if we do the differentiation, then this is what we're gonna get, times of minus 1. Yes or no? Second formula, apply it over here, you will get to know. Over here also, if you apply the second formula, you will get to know that it is coming out to be something like this. I said, okay, let's differentiate the numerator as well. It is going to be something like this. Okay, over here, if you see, it is going to be something like this. And then the differentiation of a constant is nothing but equal to 0 only. I said fine. ln3 can be taken common from the numerator as well as from the denominator and can be cancelled quite comfortably. And now if you think there is no indeterminate form, I can feel it. Can you also feel the same. Let me write it down so that you guys can feel it. Now if you see x equals to 2, if you put over here, then this is going to be what? This is going to be 6 in the numerator, and in the denominator, if you see, it is going to be 3 minus 3 by 2, that is 3 by 2. So what is the answer coming, kids? It is going to be 4. Yes, this is the answer. Since there is no indeterminate form, so what we have done, we have directly substituted x equals to 2, and we have got the answer as nothing but equal to 4. You can solve this question by multiple other methods as well, but I will recommend you this particular method because this is something which we should use in class 12th, so that problems can be solved a bit easily, and that too in less amount of time. Okay, let's talk about this particular thing. Now, we can solve this question by multiple methods. We can solve it by rationalization. A lot of guys who have already studied limits can feel this. But I would like to give you another method over here. 1 plus x to the whole power n is roughly equal to 1 plus nx. You might have studied this thing in binomial theorem. Through binomial theorem. One plus nx plus n into n minus 1 x square by 2 plus n into n minus 1 into n minus 2 x cube by 3 and so on like that. Yes, so very same thing if you apply over here, and if x is here, x is infinitesimally small. Infinitesimally small means it is very small, like 0.000000001 like that. So since y is moving towards 0, y to the power 4 is going to be very small value or not. So this 1 plus y to the power 4 to the whole power 1 by 2 can be written as 1 plus 1 by 2 times of y to the power 4. If you put this particular thing over here in the problem, then the question will become what? Under root 1 plus this particular thing can be rewritten as 1 plus y to the power 4 upon 2 minus root 2 divided by y to the power 4 limit x tending to 0, limit y tending to 0. Okay, I said fine. Now this very same thing can also be rewritten as this particular thing. I said fine. Okay, if you take a root 2 common from both of these things, okay, if you take 2 common from here, then over here 1 will remain, and from here also if you take 2 common, then over here what is going to come? Then over here something like this is going to come. Yes or no, beta ji? Yes, I said fine. Okay, now if you take root 2 common, it is going to be what? It is going to be under root 1 plus y to the power 4 upon 4 minus 1 divided by y to the power 4. Now understand over here that here also we can apply the same thing that we have studied over here, this one. So this particular thing can be written as 1 plus 1 by 2 into y to the power 4 upon 4, that is this particular thing can be written as 1 plus y to the power 4 by 8. So let me put it over here. The moment we put this particular thing over here, this is going to be what? Root 2 times of 1 plus y to the power 4 upon 8 minus 1 divided by y to the power 4. This 1 and 1 gets cancelled from here. So over here you are getting what? Over here you will be getting something like this. Let me write it over here for you people. Limit y tending to 0 root 2 times of y to the power 4 upon 8 divided by y to the power 4. So this y to the power 4, this y to the power 4 cancelled, and you are getting 1 by 4 root 2 as the answer. So your answer is going to be option A. So this is some concept which I wanted to teach you, that 1 plus x to the whole power n can also be approximated to 1 plus nx, and if you use this particular thing over here, you can solve the question in comparatively lesser amount of time. Whenever you see such kind of under roots, one thing has to come in your mind, that you guys can apply rationalization method. And also one more method, if I tell you this is tending to 0 upon tending to 0 form, this is moving towards 0 since y is moving towards 0, this is moving towards 1 plus 1 root 2 minus root 2. So this is tending to 0. Upon tending to 0 form, you guys can apply L'Hopital rule as well over here to solve this particular problem. There has to be no difficulty at all. Now this is something very important. Limit x tending to a, sine of f of x upon f of x is equals to 1. Understand, few things are very important over here. This thing and this thing, they are same things written over here. And as x approaches a, this f of x has to approach towards 0. This f of x has to approach 0. Then only the value of this limit is going to be nothing but equal to 1. The same thing happens with tan as well. The same thing, exactly similar thing happens as well with tan. These two things are same, and as x is moving towards a, this f of x is moving towards 0. Then we say that the value of this limit is nothing but equal to 1. Okay, number 1. This is something different. Let me tell you this particular thing. Even though we say that these are the limiting values equals to 1, but I would like to tell you one thing over here. These are very important. Even though this thing and this thing are same written, okay, and as x is moving towards 0, this thing is moving towards 0, so the answer has to be 1. We say that the answer is 1, but the answer is slightly lesser than 1. Slightly lesser than 1 means it is nothing but equal to 0.999999999 like that. What is the purpose of this thing is, why we are studying this thing is, if I ask you limit x tending to 0, this sin x upon x, then you guys can feel that this value is slightly lesser than 1. So what is the value? This is the greatest integer function, okay? This is the greatest integer function, GIF. Since this value is slightly lesser than 1, so the greatest integer value is going to be what? 0. So over here the answer is 0. Whereas if I ask you the limit for this particular question, limit x tending to 0, sin x upon x, greatest integer function, then this is nothing but 1, because we write down the answer of this limit as 1, so the greatest integer of 1 is going to be nothing but 1 only. You must remember this, that limit x tending to 0, sin x upon x is nothing but slightly lesser than 1. Similarly, this value as well, this value over here is slightly greater than 1. So if I put a greatest integer function over here, then the value is going to be 1. Okay, so you must remember this particular thing, as this is very important. How we can feel this? We can feel it through the graphs of y equal to x. We can feel it through the graph of y equal to sin x and y equal to tan x. If you do sin x upon x and x is greater than 0, that means, don't you think if you move from here to here, the value of sin x is going to be lesser as compared to y equal to x value? Look, the green graph is coming below as compared to this yellow graph. So don't you think that numerator is smaller and denominator is bigger? If numerator is smaller and denominator is bigger, then don't you think that the value will be coming out to be lesser than 1? So that's why the thing. I hope you guys are clear with this. And over here, if you see in these two graphs, then tan x is greater than x, because tan x is coming above y equal to x graph, and that's why we can say that this value is going to be nothing but slightly greater than 1. So you remember this particular thing as well. Over here, in all these standard limits, x is in radians. Do remember this as well. Okay, let me give you an example over here. Some very important examples. If I ask you what is limit x tending to 2 pi sine of x upon x. Now, a lot of guys tell me the answer of this particular thing equal to 1, but the answer is not equal to 1. Let me tell you why. This thing is moving towards 2 pi. I said fine, and this thing is also moving towards 2 pi. Okay, this overall thing is moving towards where? Sine of 2 pi means 0. Is it tending to 0 upon tending to 0 getting formed? Even though same things are written, but when x is moving towards 2 pi, are these two things going towards 0? No, sir. So this is not an indeterminate form. So what will be the answer? Tending to 0 upon tending to 2 pi. What will be the answer? This is not even in indeterminate form. So the answer is going to be nothing but equal to 0 only. This is one such thing you must remember. Even though this and this are same, but as x is approaching this particular value, are these two values moving towards 0? If not, then this is not an indeterminate form. Okay. Yes, this is one such example. Let me tell you another as well. If I ask you something like this, limit x tending to limit x tending to limit x tending to pi sine of x degree upon x is going to be what? Or let's say something like this. This is going to be what? Now, a lot of times what happens, the kid will say that the answer is nothing but 2 by pi. Yes? A lot of times kids will say that the answer is nothing but 2 by pi. Yes? Okay. But remember that this angle has to be in terms of radians only. Okay. You must keep this particular thing in mind. Okay. Let's apply the concept that we have just studied. As x is moving towards 0, this particular thing is moving towards 0. I said fine, okay. But if very same thing is written in the denominator, then only the value of the limit is going to be 1. So this limit is now going to be 1, yes or no? And over here, if you cancel out these two, then your question will become nothing but 2 by 5. A lot of times the kids say that the answer of this particular thing is 1, but no, the answer of this particular thing is what? 2 by 5. Because if this thing is written over here and it is moving towards 0, so very same thing will be written in the denominator as well. Now this is not written, so we're going to multiply this in the numerator and the denominator both, and then this limit becomes 1. So 2x upon 5x, x and x cancelled. What we are remaining with is 2 by 5. Alright, here we go. Limit x tending to 0, this particular thing. Okay, you guys can solve these questions by L'Hopital rule as well, because over here you guys can feel that no indeterminate form is there. No, indeterminate form is there, because this is tending to 0. This is also tending to 0. So one method is you guys can solve these questions by using LH rule. So this is going to be limit x tending to 0, 3 minus, what is the differentiation of sin x? Cos x. What is the differentiation of tan 2x? It is going to be sec square 2x into 2 minus 1. So over here if you see now there is no indeterminate form, so direct substitution, do it and get the answer. Okay, yep. Let's talk about this particular question. Limit x tending to 0, x into cot. I don't like cot in my questions, so let's convert this cot into tan first. Okay, this limit is what we want to evaluate. So let's say we are dividing this by x square and this by x square. So we guys can say that this limit is nothing but equal to 1. I said fine, okay. Here if we divide by 4x and 4x, then this limit is going to be nothing but 1. Okay, I said fine. So this particular thing is going to become something like this. Limit x tending to 0, x into tan square 2x divided by 4x cube. Yes. So this is going to be what? X and x cancelled away. So over here 2 will come. And now we can write down this very same thing like this as well. Then the answer is going to be nothing but equal to 1 only. Yes or no, beta ji? Yes, that's it. Right? I hope you guys are clear with this. Let's talk about this particular question. Whenever you see such kind of under roots, number one thing in question of limits, when x is moving towards 0, this expression will move towards 0. This expression as cos 0 will move towards 1, so this will move towards root 2, and in the denominator root 2 minus root 2 will move towards 0. So this is a tending to 0 upon tending to 0 kind of a form. I said okay. Tending to 0 over tending to 0 kind of a form is there. Now there are multiple ways. Number one, we can apply LH rule, or whenever we such kind of things, under roots and all, we guys can apply rationalization as well. So let's do this question using rationalization. Root 2 minus under root 1 plus cos x sine square x over here. Then over here we're gonna multiply and divide by something like this. Now in the denominator what will happen? A plus b into a minus b. So that is going to be a square minus b square. So it is going to look something like this. Okay, and in the numerator it is going to be something like this. I said fine. Okay, in the denominator it is going to form 1 minus cos x, and over here it is going to be sine square x times of under root 2 plus under root 1 plus cos x. Okay, this particular thing over here can be written as 2 sine square x by 2. I said fine. Okay, and this thing over here, if you see, sine x can be written as 2 sine x by 2 cos x by 2 ka whole square. Now upon cancelling few terms over here, this expression will become something like this: 2 cos square x by 2 times of root 2 plus under root 1 plus cos x, which is not an indeterminate form anymore. So simply put x equals to 0, you're gonna get your answer, bachcho. So this is going to be 2 times of 2 root 2. 2 times of 2 root 2 is going to be what? 4 root 2. That is C for Calcutta is going to be the correct answer. I hope you guys are fine with this particular thing. Okay, moving ahead. Sine pi cos square x. Now understand, as x is moving towards 0, this expression will be moving towards pi, and sine of pi will be moving towards 0. Yes or no? And the denominator is already moving towards 0, so this is tending to 0 over tending to 0 form. But can I say that the answer is going to be 1? No. Why? Because this thing and this thing are not equal, and also they are not going towards 0. If you see over here, this is moving towards pi. Yes or no? So what we can do is, we guys can write down this particular question. We guys can solve it in multiple ways. We guys can solve this question by LH rule and so on. But I would like to teach you something else over here. We guys can write down this same thing like this as well. Because sine of pi minus theta is what? Sine theta only. So what we can do is, we can write down this particular thing as a sine of pi. Pi, if we take common, it is going to be 1 minus cos square x. 1 minus cos square x is nothing but sine square x. Yes or no, beta ji? Okay. So pi we have taken common, and it has become pi times of 1 minus x square, 1 minus cos square x, and 1 minus cos square x is nothing but sine square x. So now x is moving towards 0, so this thing is moving towards 0, yes or no? So very same thing, if I multiply and divide over here, then this thing over here is going to be what? This thing is going to be nothing but 1. I said fine. Okay, limit x tending to 0, it is going to be pi into sine square x upon x square. I hope you guys can visualize that the value of this expression is going to be nothing but 1. So the answer is going to be nothing but pi only. So the answer is going to be D for Delhi. I hope you guys are clear with this particular method as well. You guys can solve this question in multiple ways. Alright, let's talk about this JEE Advanced 2020 question. Alright, let's take this up. Limit x tending to pi by 2. Okay, first we should check whether it is an indeterminate form or not. So x is moving towards pi by 2, so this is going to be 1, and sine of 3 pi by 2 is nothing but minus 1. So the numerator is moving towards 0, no doubt about that. If we talk about denominator, then this term is 0 because sine of pi will become 0, and this is going to be what? Cos of 5x by 2, it is again 0, so 0 plus 0 will be 0. And this thing, if you see, this is going to be root 2 minus root 2, and this is going to be what? This is going to be again 0 only. So this is tending to 0 upon tending to 0, kind of an indeterminate form. Now how we should solve this problem? We need to do some manipulations so that we guys can find out the answer of this particular thing. So in the numerator, if you observe, sin c plus sin d can be applied, which we have learnt in trigonometry. So 4 root 2 times, what is sin c plus sin d? It is 2 times of sin c plus d by 2, means 3x plus x by 2. So that is going to be 2x into cos of c minus d by 2. So 3x minus x by 2, yani 2x by 2, that is equals to x. Okay. Whole divided by, over here if you see, this is 2 sin a sin b. 2 sin A sin B can be written as cos of A minus B minus cos of A plus B. Yes or no? Cos of A minus B, that is x by 2, minus cos of adding these two things together, 2x plus 3x by 2. So it is going to be 7x by 2. I said fine, okay. Moving ahead, then this cos 5x by 2 as it is. Okay, minus times of, if we take root 2 common from here, then it is going to be 1 plus cos 2x. Okay, minus cos 3x by 2. Now this particular thing over here, the moment you see 1 plus cos, your mind should tell you that this can be written as 2 cos square x. I said fine, okay, let's move ahead. Anything which we can cancel in the numerator and denominator? So far I don't think anything we can cancel. So let me write down these things again. So this particular thing can be written as 4 root 2 into 2 into sin 2x into, or we can write down this sin 2x also as 2 sin x cos x. So I said fine, okay, 2 sin x cos x into cos x divided by, if we take these two and apply cos c minus cos d, then the thing is going to be the same only. So if we want to apply, because ultimately our agenda is what? To cancel something from the numerator and denominator. If you want to cancel out anything, then we will have to take that particular thing as common. Yes or no? So over here you guys can feel that we need to have 2 cos square x common, because this 2 cos square x is ultimately making the numerator equal to 0. So ultimately our agenda is to have 2 cos square x common. That's why we have written this 1 plus cos 2x as 2 cos square x. I said fine, okay. Now if we apply cos c minus cos d in this and this, anything we are getting cos c minus cos d, we gonna get 2 times of sine, adding the two things by 2, that is x by 2 plus 3x by 2 means 2x by 2 is going to be x. I said fine, okay. And then sine of that thing minus this, so 3x by 2 minus x by 2 is going to be 2x by 2, that is x, and by 2 is what we're gonna do. So ultimately we're gonna have something like this. I said fine, okay. And if we apply this and this, cos c minus cos d in these two, what we're gonna get? 2 times of sine of this plus this by 2, that is 6x by 2, that is 3x, times 7x by 2 minus 5x by 2, that is 2x by 2, that is x divided by 2, minus root 2 times of 2 root 2 times of cos square x. Now can we take cos square x common from these following places somehow? Our agenda should be to take cos square x common from these kind of things. The moment we are done with that, I think we will be able to solve the question, because ultimately in the numerator, who is creating problems for us? Who is creating problems for us? This 2 cos square x. So we have to see about 2 cos square x. Anything which can be done for this 2 cos square x? Let's see. If you see over here and here, so we add these two, so it is going to be 4x by 2, that is 2x by 2 if we have done. So it is going to be x only. I said fine, okay. This is going to be 2x by 2, that is x, okay, x by 2. And if we talk about this, then this is going to be 2 times of this plus this, that is 3x by 2. 6x? No. 6x by 2, that is 3x, okay. And 7x by 2 minus 5x by 2, that is 2x by 2, that is x by 2, okay. Yep, this is what we have written. Can we cancel anything? Can we cancel anything? Can we cancel anything, kids? If yes, we will be done with our problem. So let me add one page over here, and the moment we cancel out the terms from here, we will be able to solve the question, kids. Okay, let's simplify it over here only, because otherwise there will be so much information to take on to the next page. I said fine, okay, this is having 2 sin x by 2 and this is also having 2 sin x by 2. So from here, let's do one thing. Let's take, I'm talking about this white portion only, okay. Let's take 2 sin x by 2 common. The moment we do that, we're going to have sin x by 2 plus sin 3x. No, sin x plus sin 3x. And if you further simplify this, then it is going to be 2 sine x by 2 sine c plus sine d is what you can apply. You're going to have 2 sine c plus d by 2, so that is 2x, into cos c minus d by 2, that is x. And over here, if you again apply sine 2x, if you again write as 2 sine square x cos square x, sorry, 2 sine x cos x. So can you see that something good is happening? I think you will be able to observe it over here, that this 2 cos square x and this 2 cos square x and this 2 cos square x will be cancelled, and you will be left out with what? You will be left out with 8 root 2 sine x. Let me write it on the next page. Limit 8 root 2 sine x divided by, and x is moving towards where? X is moving towards pi by 2. Okay. Then over here we are left out with this 2 sine x by 2 into 2 sine x minus root 2. Now, is this an indeterminate form? Let's check it out. I don't think it is an indeterminate form, because over here this is going to be 8 root 2, and over here if you see, this is going to be how much? This is going to be 1. This is going to be 1 by root 2. So ultimately this expression can be rewritten as 8 root 2 divided by 2 root 2 minus root 2. So that is equals to 8 root 2 divided by root 2. Root 2 gone. So the answer is coming out to be 8. I hope you guys are clear with this particular question. So the answer is going to be A option. Yes, anyone is having any difficulty in this, do watch this once again. You will be able to understand, kids. Okay, if x is tending to minus 2, then over here we guys can see that this is tending to 0 over tending to 0. And when x is moving towards minus 2, this is moving towards 1 plus 1 by 4, that is equals to 5 by 4. So this is not an indeterminate form. So here in this portion we can segregate the limits first, or we can apply L'Hopital rule over here first. So differentiation, if you do sec square pi x into pi is the differentiation of tan pi x with respect to x, and over here it is going to be 1. Okay, plus 5 by 4. Now I think you guys can tell me that if limit x tending to minus 2 is written, then sec of minus 2 pi is going to be what? Sec of minus 2 pi is going to be nothing but 1. Yes, so this is going to be pi plus pi by 4, pi plus 5 by 4. So pi is 3.14, this is 1.25. Okay. So 3.14 plus 1.25, this value is going to be greater than 4. So the answer is going to be this. Yes, everyone have a look at this. Okay, talking about this particular thing over here, it has to be extending to 0 minus. Okay, it has to be extending to 0 minus. Okay, greatest integer function is involved in the problem. Okay, extending to 0 minus means x is equal to what? Minus 0.0000000001. Yes or no? So if we talk about greatest integer of x in this particular case, don't you think that it is going to be nothing but minus 1? I said okay. If we talk about greatest integer of x, then don't you think that it is nothing but going to be 0.0000000001 only? Okay, if we put these values in this original problem over here, limit x tending to 0 minus x times of greatest integer of x will become minus 1 plus, since the modulus is opened with a minus sign. Why? Because I hope you know that the modulus will be opened with a minus sign over here, times sine of minus 1 divided by, this is going to be minus x. Can you solve this particular question now, everyone? If we see over here, x and x is cancelled, And over here the same problem can be written as 1 plus x times of sine of minus 1. So x is moving towards 0 means the answer will be moving towards sine of minus 1. That is nothing but equal to minus sine 1. Yes, so the answer is going to be option A. This problem was asked in JEE Main 2019. Okay, let's talk about this particular problem. In every question of limits, we first see whether it is an indeterminate form or not. So this is moving towards 0 and this particular thing is moving towards 1. This particular thing is moving towards 1 when x is moving towards 0. So this is tending to 0 upon tending to 0 form. Whenever you see such kind of under roots, rationalization must come in your mind. So if you do the rationalization, I am doing the rationalization directly, okay. The moment you make plus over here and multiply it in the numerator and denominator, you're going to get something like this. X square plus 2 sine x plus 1 minus sine square x minus x plus 1 times of this thing with a plus sign will come in the numerator, under root x square plus 2 sine x plus 1 plus under root of sine square x minus x plus 1. Yes, okay, if we solve this particular thing, then over here we can observe that 1 and 1 will be cancelled. I said fine, okay. Anything else which is getting cancelled over here, you guys can identify and can observe whether indeterminate form is getting formed or not. I said okay, let's move ahead. Limit x tending to 0, it is going to be x plus 2 sine x. Okay, it is going to be x square minus x, minus minus will become plus, okay. And then plus 2 sine x minus sine square x. And then 1 and 1 will be cancelled over here. So if x is moving towards 0, then this thing is moving towards root 2. So I am writing it directly. Why? Because I can split the limit about this multiplication and can write out the limit of that particular thing. Okay, so that is going to be 2, not root 2. Because when x is moving towards 0, this thing will move towards 1, this thing will also move towards 1, so this will be moving towards 2. I said fine, now our agenda is to solve this particular thing. So we guys can either apply L'Hopital rule, because it is tending to 0 over tending to 0 form. So let's apply LH rule over here. The moment you apply LH rule over here, it is going to be limit x tending to 0, 1 plus 2 cos x divided by, it is going to be 2x plus 1 plus 2 cos x minus 2 sin x cos x. So if you see over here, if x is moving towards 0, then this expression will move towards 0, this will move towards 2, this will move towards 3. So 3 plus 2 will move towards 5 and this numerator will be moving towards 3. So the answer is moving towards 3 by 5, yes or no everyone? Okay, wait a minute. X square plus x, so that is going to be 2x plus 1. Okay, 2 sin x minus sin square x will become 2 cos x minus 2 sin x cos x. Okay, so if x is moving towards 0, then sin x will move towards 0. So this is going to be, okay, 1 plus 2, 3 upon 3. So this will move towards 1. So the answer is going to be 1. Yes? Yes, have a look at this. This problem was asked in JEE Mains 2019. Limit of the form tending to 1 to the power tending to infinity. This is a very, very, very important category. Whenever such kind of a thing is given to you, over here this 1 is very important plus. If this thing move towards 0 and if this power tends towards infinity, then the form is nothing but tending to 0 to the power, tending to 1 to the power, tending to infinity. So we can write down the same limit like this. How we have written this particular thing, let me tell you. E to the power same limit x tending to a, and whatever is the base function, subtract 1 from it. Whatever is the base function, subtract 1 from it. So you're going to have f of x and then multiply whatever is written in the power. So that's how you calculate this particular functions. Okay, I will tell you about this. We're going to take a lot of problems based on this. So here we go, bacho. Limit x tending to 1, f of 1 plus x upon f of 1 to the power this particular thing. This is going to be f of 0. Yeah, this is going to be f of 0. So since limit x tending to this is there, so I can see that this thing will be moving towards 1. So f of 1 divided by f of 1 will be moving towards 1 raised to the power 1 by tending towards 0, that is tending to 1 to the power tending to infinity. Yes or no? So whenever this kind of form is there, what we do, we write this expression equals to y limit x tending to 0 f of 1 plus x divided by f of 1 raised to the power 1 by x. Now take logarithm both sides. Whenever in power is variable, take logarithms both sides. So the moment you take it, you're going to have limit x tending to 0. This 1 by x will come in front. Ln f of 1 plus x upon f of 1 will come. And this very same thing, you guys can apply the property of logarithm over here, that is ln a minus ln b. So this can be written as ln f of 1 plus x minus ln f of 1. Yes or no, beta? So the moment you apply this particular thing over here, you're going to have ln y equals to limit x tending to 0, x in the denominator, ln 1 plus f of 1 plus x minus ln f of 1. So if this is the thing, then since x is moving towards 0, so this thing is moving towards ln 1 minus ln f of 1. So tending to 0 upon tending to 0 form is there. So we guys can apply L'Hopital rule over here. So ln y equals to limit x tending to 0. In the denominator, we're going to write down 1. And if we do the differentiation of this, then we're going to have something like this. Yes, and that this is the difference. This is a constant thing, so the differentiation is going to be 0 only. So what we have got so far is ln y equals to limit x tending to 0. Let me write it in more simpler form. It is nothing but f dash of 1 plus x divided by f of 1 plus x. So this is what we do have. So this can be further written as ln y equals to limit x tending to 0, or we can remove this limit because we guys can write down this particular thing as f dash of 1 upon f of 1. Now the value of f dash of 1 was given to me 6 and the value of f of 1 was given to me 3. So this is 6 upon 3, that is equals to 2. So the value of ln y is nothing but equal to 2, means y equals to e to the power 2. So the limit is coming out to be what? The limit is coming out to be e to the power 2. Have a look at this problem once again. A very, 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 very good problem. I hope you guys are clear with this problem, bacho. Okay, let's talk about this particular thing. I'm giving you this particular question as homework. You guys gonna attempt it because these are some amazing problems that I have clubbed for you guys. Okay, sometimes in the questions of limits, we need to calculate LHL and RHL separately. A lot of guys are confused about these things, sir. When do we need to calculate LHL and RHL separately? So let me tell you, whenever under root is there, greatest integer function is there, fractional part function is there, whenever these things are there, you have to calculate LHL and RHL separately. Whenever these kind of things are there in the problem, under root, greatest integer function and fractional part things, you have to calculate LHL and RHL separately. Over here, if such kind of a thing comes to you, then this can be written as x equals to 1 plus h. Why? Because we are talking about a value greater than 1. 1 plus means a value greater than 1. So this same expression can be written as a limit h tending to 0, greatest integer of 1 plus h minus 3. So this same question can be rewritten as a limit h tending to 0 minus 2 plus h. Now h is infinitesimally positive small number always. So if you do this, don't you think that the thing inside this is going to be what? Minus 1.9999999 something. What is going to be the greatest integer of this? Is it going to be minus 2 or not? So minus 2 is the answer for this particular thing. Over here also we're going to do the same thing. We're going to take h tending to 0 and in place of x we're going to put 3 plus h. Now h is what? H is 0.0000000000001. Do put it and have an idea from here. This particular third problem I'm leaving as part of homework. Okay? Yeah, that's it. Now I think you guys will be able to solve this kind of question. Homework number 2. Because limits can be separated about this plus and minus as we have already seen, and the problem will be able, and you will be able to solve the problem. Similarly, this also homework number 3 I'm assigning you. I think you will be able to solve this. Over here, I think this can also be solved. So this is homework number 4. Okay. Yep. If we talk about this particular thing, then LHL and RHL will be written from here. Yes or no? Because LHL means slightly lesser than 0. Yes, and RHL means slightly greater than 0. So let's talk about LHL at x equals to 0. That means in place of x, we're going to put 1 minus h. So the moment we do this, limit h tending to 0. And in place of x, if we put 1 minus h divided by greatest integer of 1 minus h. Okay, not 1 minus h, balki 0 minus h, sorry. Zero minus h. So the moment if you put it over here, the denominator is going to be what? Minus 1. And numerator is going to be what? Sine of minus 1. So it is going to be nothing but ultimately sine 1 only. Yes or no? Similarly, RHL can be evaluated. And RHL is undefined. Yes or no? Because denominator will become exact 0 in that case. So RHL is undefined over here. I hope you guys are clear with this. So this limit does not exist. That's it for the day. So here only we're going to end the session. Don't forget to solve the DPPs and make command over this particular topic. Though in the excellence batch also we will be taking this topic in detail. So keep learning, keep shining, keep rocking, keep enjoying. Let's make most out of this. Thank you so much. Bye bye. Take care. Happy learning.